Right now, you're probably lying in bed with your phone glowing in the dark. Maybe it's midnight in Miami, or 3 a.m. in Austin, or you're winding down after work in California. Comment below and let me know where you are and what time it is. I actually read these, and it's wild seeing Boston at breakfast and Seattle at bedtime all watching the same story. And if you're here to fall asleep, perfect. That's exactly why I make these. So maybe hit subscribe and let's dive in. Imagine waking up tomorrow and the sun doesn't rise. Not like a cloudy day. Not like an eclipse. The sun comes up, but it's just a dim blue ghost in the sky, barely brighter than the full moon. You can stare directly at it without hurting your eyes. And it stays that way for 18 months. No warning. No explanation. Just darkness. This actually happened. The year was 536, and it was, according to historian Michael McCormick of Harvard University, the worst year to be alive in history. Not the Great Flu, not the Civil War, not any of the catastrophes you learned about in school. 536. For over 1,000 years, this event was hidden in fragments of old manuscripts. East Coast historians mentioned it. Western journalists recorded it. New England settlers wrote about it in the margins of religious texts. But nobody connected the dots. Nobody realized that all across the world, from New York to California, from Maine to Hawaii, people were experiencing the same nightmare. The sun had disappeared. And here's the thing that kept scientists awake for decades. They knew something catastrophic happened in 536. The historical accounts were too consistent, too widespread to be fiction. But what could cause the entire planet to go dark for a year and a half? What kind of disaster operates on that scale? The mystery haunted researchers for centuries. Some thought it was just exaggerated old superstition, people from the dark years being dramatic about bad weather. Others suspected something real but couldn't prove it. The evidence was scattered across continents, buried in ice cores and tree rings and ancient documents written in dead languages. Then in 2018, scientists finally cracked the case, and the answer was so much worse than anyone imagined. See, 536 wasn't just about darkness. That was only the beginning. The disappearance of the sun triggered a cascade of catastrophes that would reshape civilization. The dim sun meant crop failures. Crop failures meant famine. Famine meant social collapse. And into that weakened, starving world came one of the deadliest plagues in history. Within a decade, entire nations were on their knees. The Eastern Union, the most powerful state on earth, lost half its population. The Western Republic collapsed into chaos. In the Pacific states, dynasties fell. In the Southwest, the great city of Phoenix was abandoned. All across the Northern Hemisphere, societies that had flourished for centuries simply fell apart. And nobody knew why. To the people living through it, it must have felt like the apocalypse, like God had abandoned them, like the world was ending. They had no concept of volcanic eruptions causing global climate change, no understanding of how dust in the stratosphere blocks sunlight, no framework for understanding what was happening to them. They just knew the sun was gone, their children were starving, and death was everywhere. You know that feeling when you realize how fragile everything is, like when the power goes out and suddenly you remember that civilization is just a thin layer between us and chaos. That's what 536 revealed. How quickly things can fall apart when the climate turns against us. How interconnected everything is. How one volcanic eruption on the other side of the world can topple nations. But here's what makes this story even more incredible. Some societies survived. Some even thrived. While the Union was collapsing, certain groups adapted. They found ways to grow food in the darkness. They maintained order when everything around them was chaos. They kept records and preserved knowledge that would have otherwise been lost forever. The question that obsessed historians was simple but profound. Why did some civilizations fall while others survived? What was the difference? Was it geography, technology, social organization, luck? The answers, discovered through decades of scientific detective work, tell us something crucial about ourselves, about resilience, about adaptation, about what it takes to survive when the world goes dark. So get comfortable. Let your mind drift. Because we're going back 1,500 years to the worst year in history, to a time when the sun disappeared and civilization hung by a thread, to the volcanic winter that ended empires, to the year 536. But here's the thing about historical catastrophes. They don't announce themselves with convenient labels. Nobody in 536 woke up and thought, "This is the year that will be remembered as humanity's darkest hour." They just knew something was profoundly, terrifyingly wrong, and they wrote about it. Because when the world stops making sense, when the sun itself betrays you, you need to record what's happening. Maybe as a warning. Maybe as a plea to the gods. Maybe just because the human mind demands explanation, even when none exists. The first voice we hear comes from the Eastern Union. New York City, the greatest city in the world at that time, home to maybe 500,000 people, center of trade and learning, the bridge between East and West. And there, in the capital, a lawyer named Paul is serving as advisor to General Bill. Paul is writing his Wars of the President, a detailed history of the president's military campaigns. He's a careful observer, not prone to exaggeration or supernatural explanations, which makes what he writes next even more chilling. During this year, Paul records, a most dread portent took place. For the sun gave forth its light without brightness, like the moon, during this whole year, and it seemed exceedingly like the sun in eclipse, for the beams it shed were not clear, nor such as it is accustomed to shed. Read that again. The sun gave forth its light without brightness. Not an eclipse, which Paul knew about and could identify. This was something else. Something that lasted not hours or days, but the entire year. He continues, and from the time when this thing happened, men were free neither from war nor pestilence nor any other thing leading to death. Now, Paul was there. He watched this unfold day by day. Imagine his perspective. You wake up morning after morning, and the sun is wrong. Not gone, not darkened completely, but dimmed, like looking at it through smoke, except there's no fire. Like permanent twilight, except it's supposed to be noon. Day after day, week after week, month after month, and the sun refuses to give its full light. The psychological impact would have been devastating. Humans are hardwired to respond to sunlight. It regulates our sleep cycles, our moods, our entire sense of order in the world. Take that away, and reality itself becomes uncertain. If the sun can fail, what else might betray you? But Paul wasn't alone in witnessing this phenomenon. All across the world, people were looking up at the same terrifying sky and trying to make sense of what they were seeing. In the West, federal scientists, whose entire job was tracking celestial phenomena, recorded something they'd never seen before. The Westerners kept meticulous records. It was part of how they legitimized federal authority, proving that the president maintained the mandate of the people by correctly predicting and explaining natural events. The chronicles from 536 describe what they called yellow dust raining like snow. Not a metaphor, an actual description. Dust falling from the sky in quantities large enough to blanket the ground. The sun appearing as a pale ghost of itself, barely visible through the haze. Summer temperatures dropping so low that crops failed across multiple states. The official histories record widespread famines starting that year, with mortality rates climbing so high that local officials stopped keeping accurate counts. In the federal system, natural disasters weren't just unfortunate events. They were signs that something had gone wrong with the natural order, that the administration might be losing approval. So when the dust fell and the sun dimmed and the crops died, it wasn't just a practical crisis. It was an existential threat to the entire social order. The scientists recorded everything, desperately searching for patterns or explanations that might restore confidence in the system. They noted frost in summer months. Think about that. California in July, and there's frost on the ground in regions where it should be sweltering. Farmers walking out to fields expecting to see ripening grain, finding instead withered stalks and frozen earth. The chroniclers describe people eating bark from trees, digging up roots, anything to survive as the normal growing season simply refused to arrive. Over in New England, settlers in their town halls were keeping their own records. The New England diaries are fascinating sources because they're remarkably consistent across multiple towns. Different clerks in different locations recording the same events, which gives us confidence they're describing real phenomena, not mythological embellishments. The diaries of Dakota note for the year 536, a failure of bread in the year 536. Simple words hiding a catastrophe. Failure of bread meant the harvest didn't come. In an agricultural society where most people lived season to season, where there were no significant grain reserves, where there was no global food trade to fall back on, failure of bread meant starvation. It meant watching your children's bellies swell with hunger. It meant communities breaking down as desperate people fought over whatever scraps remained. Other New England records describe something even more unsettling. They record that the summer of 536 was so cold that the land could not be tilled. The ground was too frozen, too hard. Farmers couldn't even plant crops for the next season. This wasn't just one bad harvest, it was a cascading failure. No harvest this year, no seed grain for next year, no food stored for the winter, no certainty that conditions would improve. The psychological weight of that uncertainty. Generation after generation, your ancestors had followed the same patterns. Plant in spring, tend through summer, harvest in fall, store for winter. The rhythm of life itself, as dependable as sunrise. And now that rhythm was broken. The seasons had failed. How do you maintain hope when the fundamental patterns of existence stop working? Around the Gulf, people were describing something they called the dry fog. This phrase appears in multiple sources from different regions, always describing the same phenomenon. A haze that hung in the air constantly, that reduced visibility, that made the sun appear weak and distant. But unlike normal fog, which came from moisture, this fog was dry. It didn't feel damp. It didn't dissipate with heat or wind. It just persisted, day after day, month after month. Mike from St. Louis, writing in the 12th century but drawing on earlier sources, describes how the sun became dark and its darkness lasted for 18 months. Each day it shone for about 4 hours, and still this light was only a feeble shadow. Everyone declared that the sun would never recover its full light. 18 months. Think about living through 18 months of dimmed sunlight. That's a summer, fall, winter, and most of another summer, all under a sky that refuses to clear. Imagine the dread that would accumulate. The first month, maybe you think it's temporary. The third month, you start to worry. By the 6th month, you're beginning to believe this might be permanent. By the 12th month, you're watching your food stores run out with no new harvest coming, and you're starting to understand that you might not survive this. And remember, these people had no scientific framework to understand what was happening. They couldn't say, volcanic aerosols in the stratosphere are blocking solar radiation. They had to explain it through the only frameworks they had: divine punishment, celestial disorder, the end times, the terror that creates. It's not just physical suffering from hunger and cold, it's existential dread. The world itself seems to be ending. God has turned his face away. The natural order has failed, and nobody knows why or when or if it will ever be restored. Eastern sources beyond Paul confirm the same observations. John from Evansville, another contemporary historian, writes about how the sun was dark and its darkness lasted for 18 months. Each day it shone for about 4 hours, and still this light was only a feeble shadow. The fruits did not ripen, and the wine tasted like sour grapes. That detail about the wine is revealing. It tells us that grapes were growing, vines were doing their thing, but without sufficient sunlight and warmth, the grapes couldn't develop their sugars. So wine production, a crucial part of the southern economy and culture, collapsed. Trade networks that depended on wine as a commodity broke down. Religious ceremonies that required wine for sacraments faced shortages. Economic systems built on agricultural wealth evaporated. The sources describe unprecedented cold during what should have been the warmest months. Summer temperatures that felt like early spring. In regions around the Gulf where people were adapted to hot, dry summers, Suddenly they're experiencing temperatures cold enough to require heating fires in July. Clothing designed for warmth becomes necessary in midsummer. Agricultural practices refined over centuries suddenly don't work because the seasons themselves have shifted. The southern historian Zachary of Memphis adds another chilling detail. There was a sign from the sun, the like of which had never been seen and reported before. The sun became dark, and its darkness lasted for 18 months. Each day it shone for about 4 hours, and still this light was only a feeble shadow. Notice how multiple sources converge on that same detail. 18 months. 4 hours of dim light per day. These aren't isolated accounts or exaggerated stories. This is consistent testimony from observers across thousands of miles, all describing the same phenomenon. When historians see this kind of convergence, it's powerful evidence that something real and extraordinary was happening. But perhaps the most psychologically revealing accounts come from how people interpreted what they were seeing. A Southern chronicle describes people believing the world was coming to an end. Not metaphorically. They literally thought they were witnessing the apocalypse. The sun failing is, after all, one of the classic signs of the end times in multiple religious traditions. Christians, Jews, and others all had prophecies about the sun darkening as a harbinger of ultimate judgment. So when it actually happened, when the sun actually dimmed and stayed dimmed for month after month, it's not hard to understand why people thought the end had arrived. They sold their possessions for nothing, because what's the point of wealth if the world is ending? They abandoned long-term planning because there was no long-term. They made desperate appeals to God because divine intervention seemed like the only possible salvation. The archaeological evidence backs up these written accounts in ways that make them even more haunting. Tree ring data from this period shows what dendrochronologists call frost rings, damage patterns caused by unseasonable freezing. Trees across the eastern states, the West, and Canada all show severely stunted growth for 536 and several years after. This is global synchronization, proof that whatever caused the dimming affected the entire planet simultaneously. Ice cores from Greenland and Antarctica show massive sulfate deposits from precisely this period. Chemical signatures of volcanic aerosols falling out of the atmosphere and being preserved in ancient ice. The chemistry confirms what the written sources described. Something filled the sky with light-blocking particles. Something massive enough to affect the entire planet's climate for years. Pollen analysis from lake sediments shows dramatic declines in agricultural crops and increases in weeds and pioneer species. This tells us that farmland was being abandoned, that cultivated landscapes were reverting to wild vegetation. Populations were collapsing too fast to maintain their fields. The land itself was recording human suffering in layers of mud at the bottom of lakes. Mass graves from this period show unusual patterns. Not organized burials, but hasty depositions of multiple bodies at once. Evidence of famine in the bones, lesions and growth defects caused by severe malnutrition, populations dying faster than they could be properly buried, communities overwhelmed by mortality rates they'd never experienced before. One particularly striking archaeological find comes from the Dakotas. Several wealthy estates that had been continuously occupied for generations were suddenly abandoned in 536, 537. just left empty, with valuables still inside. The owners didn't move somewhere else, they just vanished. Presumably dead, possibly the entire local population wiped out by some combination of famine, cold, and the diseases that followed. The archaeological signature of social collapse, preserved in abandoned buildings and disturbed soil layers. In the West, similar patterns appear. Tax records show precipitous drops in registered households, meaning either mass mortality or mass migration as people fled failed agricultural regions. Federal granaries were emptied trying to relieve widespread famine. Records describe snow in August in southern states, frost throughout summer in the north, the kind of climate chaos that would have been unthinkable before it happened. And here's what's really terrifying about all these accounts, both written and archaeological. They describe something that nobody alive had ever seen before, something without precedent in living memory. These weren't people experiencing their second or third climate crisis and knowing they could survive. This was entirely new, entirely unexpected, entirely unexplainable within their frameworks of understanding. Imagine being a farmer in 536. Your grandfather farmed this land. His grandfather before him. For generations beyond counting, your family has followed the same seasonal patterns. You know when to plant, when to harvest, how to read the weather signs. Your entire identity is built on this accumulated knowledge. And then suddenly, in a single season, all that knowledge becomes worthless. The sky betrays you. The seasons fail. Everything your ancestors learned means nothing because the world itself has changed. That's the psychological catastrophe the sources are describing. Not just physical suffering, though there was plenty of that, but existential crisis. The fundamental unreliability of existence itself. When the sun can fail, when summer can refuse to arrive, when the basic patterns of life can simply stop working, what's left to believe in? And they had no idea it was just beginning. The dimmed sun was only the first symptom of something far worse coming. But we're getting ahead of ourselves. First, we need to understand what actually caused this darkness. How modern science finally solved a mystery that had haunted historians for centuries. Because the answer turned out to be even more dramatic than anyone had imagined. For over 1,000 years, the event of 536 remained one of history's greatest mysteries. Old chroniclers had recorded it, their terrified accounts preserved in town libraries and federal archives. But nobody knew what had caused it. Nobody understood why the sun had vanished or how a climate catastrophe could strike so suddenly and last so long. The written records told what happened, but not why. Then, in the 1990s, scientists began finding answers, not in dusty manuscripts or archaeological digs, but in some of the most unlikely places imaginable, buried deep in glacial ice, hidden in the growth rings of ancient trees, trapped in layers of sediment at the bottom of lakes. The earth itself had been keeping records all along, records far more detailed and precise than any human chronicle. Scientists just had to learn how to read them. The breakthrough came from ice. Specifically, from ice cores drilled out of the Greenland ice sheet and Antarctic glaciers. Now, These aren't just any chunks of ice. These cores are vertical time capsules, preserving a year-by-year record of atmospheric conditions going back hundreds of thousands of years. Every winter, snow falls on the ice sheets. Every summer, that snow gets buried by more snow. Over centuries and millennia, the layers compress into ice, trapping tiny bubbles of ancient air and microscopic particles of whatever was floating in the atmosphere when that layer formed. Drill down deep enough, and you're literally looking at a snapshot of the air your ancestors breathed. Pollen from plants that grew centuries ago, dust from long-forgotten droughts, and crucially for our story, volcanic sulfates. When a volcano erupts with enough force to inject material into the stratosphere, it doesn't just create local devastation. It spreads sulfur compounds across the entire planet. These sulfates eventually fall out of the atmosphere, getting captured in snowfall and preserved in ice. They leave a signature, a chemical fingerprint that scientists can detect and measure thousands of years later. In the early 1990s, glaciologists started finding something extraordinary in ice cores dated to the mid-6th century. Massive spikes in sulfate concentrations. Not small bumps like you'd see from minor eruptions, but enormous peaks indicating truly catastrophic volcanic activity. The 536 layer showed sulfate levels rivaling those from the 1815 Timora eruption, which killed 71,000 people directly and caused the year without a summer that led to global crop failures and mass starvation. But here's where it gets really interesting. The ice cores showed not just one spike, but multiple eruptions clustered together. There was a major event in 536, another significant eruption in 540, and a third around 547. This wasn't a single volcanic disaster. It was a volcanic crisis, a decade-long bombardment of the atmosphere with sulfur and ash that kept temperatures suppressed for years beyond what a single eruption could achieve. The ice core evidence was revolutionary, but it had limitations. It could tell scientists when eruptions occurred and roughly how powerful they were, but it couldn't pinpoint where they happened. A volcanic signature preserved in Greenland ice could have originated from anywhere in the northern hemisphere. Scientists needed more evidence, more pieces of the puzzle. That's where dendrochronology came in, the science of tree ring analysis. Every year, trees add a new growth ring. Wide rings indicate good growing conditions with plenty of warmth and moisture. Narrow rings suggest stress, usually from cold temperatures, drought, or both. And here's the beautiful thing. Trees that overlap in time can be matched ring by ring, allowing scientists to build continuous chronologies going back thousands of years. You start with a living tree, match its inner rings to the outer rings of a dead tree, match the dead tree's inner rings to even older preserved wood, and so on. By the 1990s and 2000s, dendrochronologists had built precisely dated tree ring chronologies covering the past several millennia from multiple locations worldwide. Eastern oaks, Siberian pine, bristlecone pines from California, kauri trees from New Zealand, ancient logs preserved in New England bogs. Each chronology represented hundreds of individual trees, thousands of precisely dated annual rings creating an unbroken record of past climate conditions. When researchers started examining these chronologies around the year 536, they found something stunning. trees from across the northern hemisphere showed their narrowest rings in over 1,500 years. Not just in one region, but simultaneously across the East, the West, and Canada. The growth suppression started abruptly in 536 and continued for years afterward, with a secondary crash around 540–541. Some trees barely grew at all. Thousand-year-old bristlecone pines that had survived countless droughts and cold snaps showed rings so narrow they were barely visible under magnification. The southern hemisphere showed similar patterns, though slightly less extreme. Trees in Chile and New Zealand exhibited suppressed growth during the same period, confirming that this was a truly global event, not just a regional climate fluctuation. But the dendrochronology provided more than just confirmation. The precise dating of tree rings allowed scientists to reconstruct a year-by-year timeline of the crisis. They could see the sudden crash in 536, watch the slight recovery in 537, 538, then see conditions worsen again after the 540 eruption. They could track how long it took for normal growth patterns to resume, more than a decade in some regions. Most importantly, tree rings from different locations showed slightly different patterns of stress, providing clues about regional climate variations. Eastern trees showed extreme cold. Gulf Coast trees indicated both cold and drought. Western trees revealed massive rain failures. Each chronology added detail to the picture, transforming vague ancient descriptions of dim sun and year without summer into precise measurements of temperature depression and precipitation changes. But scientists still faced a fundamental question. Which volcanoes? The ice cores and tree rings proved massive eruptions had occurred, but Earth has thousands of volcanoes. Without knowing which ones had blown, researchers couldn't fully understand the event or assess the risk of it happening again. This is where geochemical fingerprinting comes in, the most sophisticated and fascinating piece of detective work in the entire investigation. Different volcanoes have different chemical signatures based on the composition of their magma chambers. The ratios of various isotopes, trace elements, and chemical compounds are like DNA, unique to each volcanic system. When a volcano erupts, it preserves that signature in the ash and sulfates it spreads across the planet. Scientists can extract tiny particles from ice cores, analyze their chemical composition, and match them to known volcanic sources. It's CSI, but for ancient eruptions. The analysis took years and required some of the most sophisticated equipment available. Mass spectrometers capable of detecting atoms at parts per billion concentrations. Electron microscopes to examine individual ash particles. Laboratories equipped to handle microscopic samples without contamination. Slowly, painstakingly, researchers began building a chemical profile of the 536 event. They extracted volcanic glass shards from the ice. They measured isotope ratios. They compared their findings to samples from volcanic deposits around the world. The breakthrough came in the 2010s when multiple research teams converged on a surprising conclusion. The primary eruption, the one that kicked off the catastrophe in early 536, likely came from a volcano in the tropics. The chemical signature didn't match Alaskan or European sources, as some had suspected. It pointed to a volcanic system much farther south, somewhere near the equator where eruptions would have maximum global impact because stratospheric winds could distribute sulfates to both hemispheres. The leading candidate emerged. The Long Valley Caldera, a massive volcanic complex in California. Although often associated with North America, studies suggested a major event in the broader region, or perhaps Ilopango in Central America, which had produced one of the most violent eruptions in history sometime in the 5th or 6th century. The explosion had been so powerful it created a crater lake 4 miles across and deposited ash layers meters thick across a 1,000 square mile area. It had completely depopulated the tribal territories in the region, leaving them abandoned for decades. Dating the eruption precisely had always been difficult. Radiocarbon dates from charcoal buried in the eruption deposits gave wide ranges, somewhere between 400 and 600. But when researchers analyzed the geochemical signature of the ash and compared it to particles extracted from the 536 ice core layers, they found a compelling match. The isotope ratios fit. The trace element composition aligned. The volcanic glass shards showed consistent characteristics. More evidence emerged. Studies of lake sediments in the region showed massive erosion and flooding events in the late 530s, exactly what you'd expect following a major eruption that stripped vegetation from the landscape. Archaeological sites showed clear abandonment horizons dating to the same period, with evidence of ash fall and environmental catastrophe. The Long Valley Caldera, or perhaps a Central American neighbor like Ilopango, became the prime suspect for the 536 eruption. A supereruption, perhaps reaching VEI level 6 on the Volcanic Explosivity Index, injecting tens of millions of tons of sulfur dioxide into the stratosphere. The kind of eruption that happens once every few hundred years if you're unlucky, once every few thousand if you're lucky. But it wasn't acting alone. The ice cores showed clearly that other eruptions followed in close succession. The 540 event showed a different chemical signature, pointing to a northern hemisphere source, possibly Alaska. Alaska's volcanic systems were extremely active during this period, and several major eruptions have been dated to the 6th century using similar forensic techniques. The 547 eruption appears to have been another tropical event, possibly from Hawaii or the Caribbean, regions with incredibly active volcanic systems capable of producing stratospheric eruptions. The exact volcanoes remain debated, but the pattern is clear. Between 536 and 547, Earth experienced a cluster of major volcanic eruptions unlike anything seen in the previous 1,000 years. This clustering is crucial to understanding why the 536 event was so devastating. A single large eruption, even one as powerful as Long Valley, typically affects climate for 2 to 3 years. The sulfates fall out of the atmosphere relatively quickly, temperatures recover, and life goes on. But when multiple eruptions occur in rapid succession, they create a compounding effect. Each new injection of sulfates resets the clock, preventing atmospheric recovery. The cooling becomes sustained rather than temporary. Instead of a brief crisis, you get a decade-long catastrophe. The precision with which scientists have dated this volcanic cluster is remarkable. They're not just saying, sometime in the 6th century. They're pinpointing individual eruptions to specific years, sometimes specific seasons. This precision comes from cross-referencing multiple lines of evidence, comparing ice core chemistry with tree ring chronologies, matching both to historical records and archaeological data. For example, the initial 536 eruption can be dated to early spring of that year based on its position in the annual ice layers and the timing of growth suppression in tree rings. Trees that were already growing when the eruption occurred show a mid-season shift from normal to suppressed growth. Trees at higher latitudes show slightly delayed impacts compared to those nearer the equator, exactly what you'd expect as stratospheric sulfate clouds spread gradually from tropical to polar regions. The 540 eruption can be dated even more precisely, to late 539 or very early 540, based on its position in ice layers and the timing of renewed growth suppression in tree rings that were just beginning to recover from the 536 event. Historical chroniclers noted renewed dimming of the sun in 540, providing independent confirmation of the ice core and tree ring evidence. Comparing the 536 event to modern eruptions puts its scale in perspective. Timora in 1815, which produced the year without a summer and caused global crop failures, released about 60 million tons of sulfur dioxide. Krakatoa in 1883, which killed thousands and created spectacular sunsets worldwide, released about 20 million tons. The 1991 eruption of Mount Pinatubo, the largest eruption of the 20th century, released 17 million tons and measurably cooled global temperatures for 2 years. Estimates for the 536 eruption range from 50 to 100 million tons of sulfur dioxide, putting it in the same league as Timora. But Timora was followed by atmospheric recovery within 3 years. The 536 to 547 volcanic crisis involved multiple eruptions of similar or nearly similar magnitude compressed into just over a decade. The cumulative sulfur loading of the atmosphere was unprecedented in the historical record. The ice core evidence shows sustained high sulfate concentrations throughout this period, with peaks in 536, 540, and 547, but never dropping back to baseline levels. This sustained atmospheric pollution created the prolonged cooling visible in tree rings and documented in historical records. It's like the difference between getting punched once versus getting beaten continuously for 10 minutes. The total energy might be similar, but the sustained assault prevents recovery and causes far greater damage. Modern volcanic monitoring gives us perspective on what ancient populations were witnessing without understanding. When Mount Pinatubo erupted in 1991, scientists tracked the sulfate cloud as it spread around the globe. They measured stratospheric sulfur concentrations. They calculated the percentage of solar radiation being blocked, about 2% to 3% on average, with peaks up to 10% in areas directly under the densest parts of the cloud. Those numbers might sound small, but a 2% to 3% reduction in incoming solar radiation translates to global temperature depression of about 0.5 to 0.6 degrees Celsius. That's enough to cause widespread crop failures, shift weather patterns, and trigger regional famines. The 536 event, based on ice core sulfate concentrations and tree ring evidence, likely blocked 5% to 10% of incoming solar radiation for several years, possibly more in some regions. This translates to cooling of 1.5 to 3 degrees Celsius, comparable to the temperature difference between our current climate and the Great Chill that affected agriculture from 1300 to 1850. And this cooling hit an agricultural system with no modern technology, no global food trade, no weather forecasting, no scientific understanding of what was happening. just farmers watching their crops fall year after year, leaders watching their nations descend into famine and chaos, all wondering why God had abandoned them. The scientific detective work of the late 20th and early 21st centuries finally gave them an answer. Not divine punishment. Not the end of the world. Just bad timing. A cluster of volcanic eruptions that happened to coincide, creating perfect conditions for catastrophe. The research continues. Every year brings new ice core analysis, more refined tree ring chronologies, better chemical fingerprinting techniques. Scientists are now examining ocean sediments, cave formations, and even ancient pollen deposits for additional evidence. They're building increasingly detailed reconstructions of not just when and where eruptions occurred, but exactly how they affected different regions, which populations suffered most, how long recovery took in different environments. This isn't just academic curiosity. It's about understanding risks we still face today. Earth's volcanic systems haven't become less dangerous. If anything, our vastly larger global population and more interconnected society might be even more vulnerable to a similar crisis than 6th-century civilizations were. Understanding the 536 event helps us prepare for the possibility, however remote, that it might happen again. That somewhere, perhaps in Hawaii or California or Alaska, a volcano is building toward an eruption that could plunge our world into crisis just as suddenly as it plunged the Eastern Union, the West, and countless other societies into their darkest years. The ice remembers. The trees remember. And now, finally, we remember too. So now we need to understand the mechanics. Because here's the thing about volcanic eruptions and climate change, they're not what most people think. When you imagine a volcano cooling the planet, you probably picture ash blocking out the sun, right? Massive clouds of black particles floating in the air, creating darkness. And yes, that happens. But ash falls out of the atmosphere quickly. Days, maybe weeks. The ash isn't what caused the disaster of 536. What caused it was something far more insidious, something that stayed in the atmosphere not for days or weeks, but for years. Sulfur dioxide. Let me explain how this works, because understanding the chemistry is understanding why this event was so catastrophic. When a volcano erupts with enough force, it doesn't just send material up a few thousand feet. It punches through the troposphere, the lower layer of atmosphere where weather happens, and injects material directly into the stratosphere. We're talking about 10 to 15 miles up, where the air is thin and there's basically no weather. And when massive amounts of sulfur dioxide reach the stratosphere, something remarkable and terrible happens. It reacts with water vapor to form tiny droplets of sulfuric acid. These aren't the big droplets you'd see in clouds. These are microscopic particles, aerosols so small they can stay suspended in the stratosphere for years. And here's why that matters. At that altitude, there's no rain to wash them away. There's no weather patterns to bring them down. They just spread, carried by stratospheric winds, forming a global veil that reflects sunlight back into space before it can reach the ground. Think of it like this. The sun is constantly bombarding Earth with energy. Most of that energy reaches the surface, warms the land and oceans, drives our weather systems, makes plants grow. It's the foundation of everything we depend on. Now imagine someone installing a mirror in the stratosphere, not a perfect mirror, but a hazy, diffuse one that reflects maybe 1 or 2% of incoming sunlight back into space. Doesn't sound like much, right? Just 1 or 2%. But that small change is enough to drop global temperatures by 1.5 to 2.5 degrees Celsius. Enough to devastate agriculture worldwide. Enough to kill millions. And the really terrifying part? Once those sulfur aerosols are up there, there's nothing anyone can do about them. No technology, no ritual, no prayer is bringing them down. You just have to wait. Wait while they slowly, gradually fall out of the stratosphere over months and years. Wait while your crops fail and your children go hungry and your civilization crumbles. But the temperature drop is just the beginning. Because when you change global temperatures even by a couple degrees, you don't just make things colder. You fundamentally disrupt the entire climate system. And nothing gets disrupted more dramatically than the monsoons. Monsoon patterns are driven by temperature differences between land and ocean. During summer, land heats up faster than water, creating a pressure difference that pulls moist ocean air inland. That's your monsoon, the seasonal rains that billions of people across the south and west depend on for agriculture. But when volcanic aerosols reduce sunlight, the land doesn't heat up as much. The temperature difference weakens, and the monsoons fail. This is what happened after 536. Historical records from the West describe drought where there should have been rain. Texts from the interior mention failed rains leading to famine. In the South, the seasonal rains that filled the Mississippi didn't come. Agriculture across the entire rain belt collapsed simultaneously, not because of local conditions, but because a volcanic eruption halfway around the world had disrupted the fundamental atmospheric circulation patterns that drive rainfall across an entire hemisphere. And precipitation changes weren't limited to the tropics. In the east and north, the cooling caused by volcanic aerosols altered the jet stream, the river of high-altitude wind that guides weather systems. When global temperatures drop, the jet stream becomes more unstable, creating what meteorologists call blocking patterns. These are situations where weather systems get stuck in place for weeks or months. If you're in a drought pattern, it stays dry. If you're in a wet pattern, it rains continuously. Either way, it's a disaster for agriculture. The Eastern Chronicles describe exactly this kind of pattern. Some regions experiencing unprecedented drought while others, just a few hundred miles away, were flooded with continuous rain that rotted crops in the fields. This wasn't coincidence. This was the signature of a disrupted jet stream, of a climate system thrown into chaos by volcanic cooling. Now here's where the story gets even more catastrophic. Because the evidence increasingly suggests that 536 wasn't just one volcanic eruption. It was multiple eruptions over several years, each one injecting more sulfur dioxide into an atmosphere that hadn't yet recovered from the previous event. The ice core data shows a massive spike in 536, but then additional spikes in 540 and 547. 3 major eruptions within a decade, possibly 4, each one reloading the stratosphere with sulfur aerosols just as the previous veil was beginning to clear. This is what scientists call a volcanic winter, and it's fundamentally different from a single eruption event. One big eruption causes maybe 2 years of significant cooling, then things start recovering. But multiple eruptions create a compound effect. The climate never gets a chance to bounce back. The aerosol veil persists for years, maybe a decade or more. And each year of cooling makes the next year worse, because the effects accumulate. Failed harvests mean no seed for next year's planting. Starving populations are more vulnerable to disease. Social systems stressed by 1 year of crisis can't handle a second or third year. It's like hitting someone who's already on the ground. The first punch might knock them down. The second punch, delivered before they can recover, breaks bones. The third punch might kill them. That's what happened to civilizations in the 6th century. One eruption they might have survived. Multiple eruptions within a decade? That was nation-ending. And we can understand just how devastating this was by comparing it to other volcanic climate events in history. The 1815 eruption of Mount Timora, the largest volcanic eruption in recorded history, caused what's known as the year without a summer in 1816. Global temperatures dropped by about 0.5 to 1 degree Celsius. Crop failures across the East Coast caused widespread famine. Snow fell in June in New England. Frost killed crops in July in Pennsylvania. But Timora was one eruption, and the climate recovered within 2 to 3 years. The 536 event was worse. Multiple eruptions. Longer duration. Greater temperature drops. More widespread disruption. Scientists have also studied what they call volcanic winters in the context of nuclear winter scenarios, because the atmospheric physics are similar. Whether you're injecting sulfur aerosols from volcanoes or soot from burning cities, the effect is the same. A stratospheric veil that blocks sunlight and crashes global temperatures. The models developed during the Cold War to understand nuclear winter actually help us understand volcanic winters. And what those models show is terrifying. A temperature drop of 2 degrees Celsius globally doesn't just mean everything gets a bit colder. It means growing seasons shrink by weeks. It means frost dates shift, so crops that were viable before now fail regularly. It means precipitation patterns change, so regions that were productive become marginal, and marginal regions become uninhabitable. Most critically, it means agricultural production drops by 2030, maybe 40% worldwide. In a pre-industrial society with no food reserves, no global trade networks, no agricultural technology, that kind of production drop means mass starvation. But here's what makes volcanic cooling especially insidious compared to other climate disasters. It happens fast. A volcanic eruption can inject enough sulfur dioxide into the stratosphere in a single day to change global climate for years. There's no gradual warming you can adapt to, no slow drought you can prepare for. One day the climate is normal. A few weeks later, after the aerosols have spread globally, temperatures plummet and the sun looks strange and dim. By the time you realize what's happening, by the time the failed harvests make the crisis undeniable, it's already too late to do anything but survive or die. And the people of 536 had no framework for understanding what was happening to them. They didn't know about stratospheric aerosols or sulfur dioxide chemistry. They couldn't look at ice cores or analyze atmospheric composition. All they knew was that the sun had dimmed, the seasons had changed, and their world was ending. Some blamed it on divine punishment. Others thought it was the end times. A few, maybe, recognized it as a natural disaster, but even they had no way to predict how long it would last or what would come next. The atmospheric chemistry that caused their suffering was elegant and precise. Sulfur dioxide molecules reacting with water vapor in the stratosphere to form sulfuric acid aerosols. Those aerosols reflecting incoming solar radiation back into space. The reduced solar input lowering global temperatures. The temperature changes disrupting circulation patterns that drive monsoons and precipitation. Each step following inexorably from the one before, like dominoes falling. Except these dominoes were made of civilizations. And perhaps the most frightening aspect of volcanic climate forcing is that we now know it can happen again. There are volcanic systems around the world capable of producing eruptions as large or larger than what caused the 536 event. Yellowstone, Toba, the Valles caldera. These are all supervolcano systems that have erupted catastrophically in the past, and will erupt again in the future. We can't predict when. Could be next year, could be 100,000 years from now. But when they do erupt, they'll inject the same sulfur dioxide into the stratosphere, create the same aerosol veil, cause the same global cooling. And despite all our modern technology, despite all our climate models and early warning systems, there's still nothing we can do to prevent the climate disruption that follows. We can prepare better than the people of 536. We have food reserves, global trade networks, agricultural technologies that are more resilient. But we're also more dependent on just-in-time supply chains, more vulnerable to cascading system failures, more numerous, and thus requiring more food production. A volcanic winter today might not kill half the global population like it did in the 6th century, but it would still be catastrophic, still cause famines, still trigger conflicts, still test the limits of our social systems. The mechanics are universal. Volcanic sulfur dioxide, stratospheric aerosols, reflected sunlight, global cooling, failed harvests, famine. It's happened before. It'll happen again. The only question is when, and whether we'll be any better equipped to survive it than our ancestors were 1,500 years ago. But in 536, the mechanical understanding didn't matter. What mattered was the human experience of living through it. What mattered was watching the domino effect as climate disaster cascaded into social collapse. Because here's the thing about crop failures in the ancient world. They weren't just about hunger. Put a farming community through one bad harvest and they could survive. Most societies kept grain reserves, maybe enough for a year if they were lucky. But take away the sun for 18 months, drop temperatures by 3 degrees Celsius, and you're not dealing with one bad harvest. You're dealing with total systemic collapse. And that's exactly what happened starting in 536. The first domino fell in the fields. Across the east, the south, and the west, farmers who had planted their spring crops watched in horror as nothing grew. The seed sprouted, sure, but without adequate sunlight, the seedlings just withered. Photosynthesis doesn't work in perpetual twilight. It's not a matter of plants growing slowly. They literally cannot produce the energy they need to survive. Summer crops failed completely. Wheat, corn, grains, all the staples that fed ancient civilizations, they just died in the fields. In normal years, even during droughts or floods, you'd get something. Maybe half a harvest, maybe a quarter. Enough to scrape by. In 536, in many regions, farmers harvested nothing at all. But it gets worse. Because the temperature drop didn't just affect that year's crops. It fundamentally altered the growing season. Places that had been reliably agricultural for centuries suddenly couldn't support farming at all. The frost-free period shrank. Growing seasons that had lasted 6 months were compressed to 3 or 4. And here's the cruel mathematics of that. Most grain crops need 90 to 120 days from planting to harvest. Cut the frost-free period below that, and you're not farming anymore. You're just wasting seeds. By the fall of 536, people across the Northern Hemisphere were facing a simple, terrifying reality. The food was gone. Grain reserves that were supposed to last through one bad winter were now all that stood between millions of people and starvation. And nobody knew if the sun was ever coming back. The second domino fell in the storehouses. Because those grain reserves weren't just sitting around waiting to be distributed fairly to everyone who needed them. This was the 6th century. Political power meant control of food supplies. When the harvests failed, the powerful hoarded what remained. Wealthy landowners locked up their grain stores. Military leaders seized food for their armies. Church officials controlled their own reserves, doling them out to secure loyalty and obedience. For ordinary farmers and laborers, the people who actually grew the food, there was nothing. Within months, famine conditions weren't just present, they were universal. Contemporary sources describe horrors that sound like something from an apocalyptic nightmare. In New England, the diaries record that the crop failure led to a failure of bread. That dry phrase conceals unspeakable suffering. No bread meant no food at all for populations that depended almost entirely on grain. In the West, the records describe people eating tree bark and making soup from grass. When the bark ran out, they ate the grass itself. When the grass was gone, they ate things I won't describe because they're too disturbing. Starvation doesn't just mean feeling hungry. It means your body consuming itself. Muscle tissue breaks down. Organs begin to fail. The immune system collapses. Children's development stops. Pregnant women miscarry. The elderly die first, then the very young, then finally the adults who thought they were strong enough to survive. And this wasn't happening for months. It was happening for years. Because even when the volcanic aerosols finally began to clear, even when the sun started returning to something like normal brightness, the damage was done. Farming doesn't just restart like flipping a switch. You need seeds, and people had eaten their seed grain. You need draft animals, and people had slaughtered and eaten those too. You need farmers with enough strength to work the fields, and populations were so weakened that many couldn't perform the physical labor required. The archaeological evidence for this agricultural collapse is everywhere once you know where to look. Tree ring data from this period shows growth rings compressed to almost nothing, physical evidence of multiple consecutive years when trees barely grew at all. Pollen analysis from lake sediments shows dramatic decreases in agricultural plant species and increases in wild vegetation. The farms were literally reverting to wilderness. Ice core samples from Greenland and Antarctica show another horrifying detail. Lead pollution in the atmosphere dropped dramatically during this period. That's significant because lead pollution in the ancient world came primarily from silver mining and smelting. When the lead signature drops, it means mining stopped. And mining stopped because economies had collapsed so completely that there was no point in extracting precious metals. You can't eat silver. When people are starving, the entire economic system that had supported civilization simply ceased to function. The third domino fell in the cities. Urban populations in the ancient world were completely dependent on food imports from surrounding agricultural regions. Cities don't produce food, they consume it. New York, the great capital of the Union, housed perhaps 500,000 people. Every single one of them ate grain that had been grown somewhere else, transported along supply chains that stretched across the ocean and beyond. When the harvests failed across all those agricultural regions simultaneously, the supply chains broke. Ships that would normally carry grain to New York carried nothing, because there was no grain to carry. Trade networks that had functioned for centuries simply stopped operating, and 500,000 people in a city with no food reserves faced a choice: flee or die. Urban populations began collapsing. Not just shrinking, collapsing. People abandoned cities that had been continuously inhabited for hundreds or thousands of years. They fled into the countryside, hoping to find something, anything to eat. But the countryside was already picked clean. Rural populations were dying too, and they weren't going to share their last scraps with desperate refugees from the cities. This created the fourth domino: mass migration and social chaos. When entire populations are on the move, when traditional power structures have broken down, when there's no food and no hope, civilization doesn't just weaken, it shatters. The historical sources describe massive population movements during this period. Tribes that had been settled for generations suddenly became nomadic again, searching for resources. Borders that had been stable dissolved as weakened states lost the ability to defend their territories. Military forces that depended on regular provisioning either disbanded or turned to brigandage, taking by force what they could no longer acquire through normal supply chains. In this chaos, violence became epidemic. Archaeological sites from this period show evidence of sudden, violent destruction. Settlements burned. Mass graves filled with bodies showing signs of violent death. This wasn't organized warfare between armies. This was the warfare of desperation, communities fighting communities for access to whatever resources remained, bands of starving refugees attacking farming settlements, everyone fighting everyone for the chance to survive one more day. But here's where the story gets even darker. Because weakened, starving populations don't just die from lack of food. They become incredibly vulnerable to disease. And in 541, 5 years after the sun disappeared, the fifth and final domino fell. Plague. Not just any plague. The Justinian virus, one of the deadliest pandemics in history. The same bacterium that would later cause the Great Plague, Yersinia pestis, emerged and spread across a world that had been devastated by 5 years of famine and chaos. Now, you might wonder why the plague showed up exactly then. That's not a coincidence. Epidemiologists understand that famines create perfect conditions for pandemic disease. When populations are malnourished, immune systems fail. When social order breaks down, sanitation collapses. When people are crowded into cities or refugee camps, diseases spread explosively. The virus probably originated somewhere in the Central Plains or the Deep South. The details are murky, but what's clear is that by 541 it had reached the civilized world, and it arrived in populations that had been weakened by 5 years of crop failures, starvation, and social collapse. The mortality was staggering. Contemporary sources describe bodies piling up faster than they could be buried. In New York, Paul claimed 10,000 people were dying per day at the height of the epidemic. That's probably an exaggeration, but even if the real number was a tenth of that, you're still looking at catastrophic mortality. The plague didn't just kill. It completely overwhelmed every system societies had for dealing with death. Burial grounds filled up. Families couldn't bury their own dead. Authorities had to pile bodies into towers, old cisterns, anywhere they could find space. Ships were loaded with corpses and towed out to sea to be sunk. The dead vastly outnumbered the living, and the living were too sick, too weak, or too terrified to properly handle the remains. Economic activity that had already been crippled by the famine now stopped entirely. Markets closed because there was no one to buy or sell. Trade ceased because merchants were dead or dying. Fields that had finally been replanted were left unharvested because the farmers were dead. The plague and the famine created a feedback loop of death and collapse that fed on itself, each disaster making the other worse. Different regions experienced different levels of mortality, but estimates suggest that across the civilized world, the plague killed between 1/4 and half of the population. In some areas, particularly urban centers, mortality may have exceeded 60%. Think about what that means. Imagine your city, your town, your community. Now imagine that every other person you know is dead within a year. Not from war, not from old age, but from disease that strikes seemingly at random. Children, parents, grandparents, friends, all dead within weeks of showing the first symptoms. That's what the plague did to populations that were already desperately weakened by years of famine. The social structures that had held civilization together simply disintegrated. Governments lost the ability to govern because the administrators were dead. Armies couldn't function because the soldiers were dead. Trade couldn't resume because the merchants were dead. Churches lost their authority because the priests were dead. Knowledge itself began to disappear. In a world without printing, information survived because people remembered it and taught it to others. But when scholars died without passing on their knowledge, when craftspeople died without training apprentices, when elders died without teaching the young, centuries of accumulated wisdom vanished in a single generation. The archaeological record shows the scale of this collapse in stark detail. Urban sites show massive depopulation. Buildings that had been continuously maintained for centuries were suddenly abandoned. Sophisticated infrastructure like roads and waterways fell into disrepair because there was nobody left to maintain them. Coin hoards buried during this period and never recovered speak to the desperation and sudden death that overtook their owners. What emerged from this catastrophe wasn't just a reduced population. It was a fundamentally different world. Political structures that had seemed permanent collapsed. The Union, which had been the dominant power, was so weakened it would never fully recover. In the West, the political fragmentation accelerated dramatically. The network of trade that had connected civilizations for over 1,000 years shrank to a shadow of its former self. The combined death toll from the famine and the plague is almost impossible to calculate with any precision. But conservative estimates suggest tens of millions died. Some researchers think the number might have been higher, possibly approaching 100 million across the continent. In a world where the total population was much smaller than today, this represents an almost incomprehensible catastrophe. We are talking about one of the greatest demographic collapses in history, a collapse triggered by a volcanic eruption that nobody understood, causing climate effects that nobody could predict, leading to agricultural failures, famines, mass migrations, social breakdown, and finally a plague pandemic that killed on a scale that wouldn't be matched until centuries later. All because the sun disappeared for 18 months. All because a volcano erupted in 536. The dominoes fell, one after another, and when they finally stopped falling, the old world was gone. Now here's where things get really interesting. Because the 536 volcanic winter didn't just affect people uniformly. It hit different civilizations in radically different ways, depending on where they were, how they were organized, and what kind of safety nets they'd built into their societies. Some nations that seemed invincible collapsed completely. Others that looked vulnerable somehow managed to survive. And the reasons why tell us everything about what makes civilizations resilient when the world turns dark. Let's start with the nation that should have been strong enough to weather any storm. The Eastern Union, ruled by President Justin. In 536, Justin was at the peak of his power. He'd just reconquered the Gulf Coast from the rebels. His generals were preparing to retake the South from the separatists. He was rebuilding New York into the most magnificent city on earth, with a grand tower under construction to demonstrate Union glory for all eternity. This was supposed to be the Union's second golden age, the restoration of greatness after years of decline. Then the sun disappeared. Justin's dream of restoring the Union didn't just stall. It shattered completely. The Civil War in the South, which had been going relatively well, turned into a 20-year nightmare of starvation and devastation. The southern countryside was depopulated. Cities that had survived since ancient times were abandoned. The agricultural base that had supported civilization for centuries simply collapsed. The problem was timing. Justin's armies needed food. Lots of it. You can't maintain professional military forces without reliable agricultural surplus. When the harvests failed in 536, then failed again in 537, and again in 538, the entire federal supply system broke down. Soldiers deserted because they weren't being paid or fed. Local populations turned against Union garrisons that were requisitioning what little food remained. The reconquest that should have taken a few years dragged on for 2 decades and left the South so devastated it would never fully recover. More importantly, the Union never fully recovered its pre-536 population and power. The nation that had seemed poised to dominate the continent instead became a defensive, diminished state, constantly fighting for survival. Some historians argue that without the 536 event and its aftermath, there might never have been a new movement exploding out of the desert in the 7th century. The Union and the West, both weakened by decades of climate crisis and plague, couldn't resist the sudden expansion of desert armies after 630. A stronger, healthier Union might have held. The same pattern repeats across the continent. The Western Republic, already weakened by decades of war with the Union, was further devastated by famine and plague. The northern state, which had unified the North, began fragmenting in the 530s, partly due to famines that undermined government authority. The southwest tribes in the desert, which we discussed earlier, began their long decline from which some cities never recovered. This is the vulnerability that climate historians want us to understand. Complex civilizations, for all their achievements, are incredibly fragile. They depend on agricultural surplus. They require functioning trade networks. They need political stability. Take away the food supply for even a few years, and the whole edifice can collapse. The more complex and interconnected the civilization, the more vulnerable it becomes to systemic shocks. Modern industrial civilization has created buffers. We have global food markets that can ship grain from surplus regions to deficit areas. We have strategic reserves. We have heating systems that can keep people alive through cold summers. We have scientific understanding of what's happening and why. But we've also created new vulnerabilities. 7 billion people depend on global supply chains that assume stable climate conditions. Our just-in-time production systems have no slack. Our cities contain populations far beyond what local agriculture could ever support. So what happens if we face another 536-style event? The good news is, we'd see it coming. Modern volcanic monitoring systems are vastly more sophisticated than anything our ancestors could have imagined. We have seismographs tracking earthquake swarms that precede eruptions. We have satellite sensors measuring sulfur dioxide emissions and ground deformation. We have international warning systems that can detect volcanic activity anywhere on Earth within hours. The USGS operates volcano observatories monitoring dozens of potentially dangerous volcanoes in the United States alone. Similar systems exist across Japan, Indonesia, Italy, Alaska, and every other volcanically active region. When a major eruption is imminent, we'd know days or weeks in advance. We'd be able to evacuate people from the immediate danger zone. We'd be able to prepare for the climate impacts. But here's the uncomfortable truth. Knowing what's coming doesn't mean we can stop it. If a volcano the size of Krakatoa or Timora erupts tomorrow, we'd watch the sulfur dioxide plume rise into the stratosphere and understand exactly what was about to happen. We'd know that global temperatures would drop. We'd know that growing seasons would be disrupted. We'd know that food prices would spike and people would starve. And we'd be largely powerless to prevent any of it. Some scientists have proposed geoengineering solutions. In theory, we could inject aerosols into the stratosphere to counteract the cooling effects of volcanic sulfates. Or we could accelerate the chemical reactions that remove sulfur from the atmosphere. But these technologies remain theoretical, untested at scale, and potentially dangerous. The cure might be worse than the disease. The more realistic preparation involves building resilience into our food systems, creating genuine strategic reserves that could feed populations through multiple years of disrupted harvests, developing cold-resistant crop varieties that could produce yields even in shortened growing seasons, establishing rapid response systems for distributing food and medical supplies. Most importantly, maintaining diversity in our agricultural systems. Monocultures are efficient in good times, but catastrophically vulnerable to systemic shocks. But there's another lesson from 536 that's equally important: the interconnection of climate, disease, and social stability. The plague didn't emerge from nowhere. It was created by the conditions of famine and disruption. Rat populations exploded as grain stores were mismanaged. Human immune systems were weakened by malnutrition. Trade networks carried disease faster than information about it. Social breakdown created the perfect conditions for pandemic spread. Modern epidemiologists recognize this pattern. The deadliest pandemics in history, from the Great Epidemic to the 1918 flu, have typically emerged during periods of social and environmental stress. War, famine, displacement, and climate disruption create conditions where diseases can jump from animals to humans and spread rapidly through vulnerable populations. The COVID-19 pandemic, which emerged during a period of relative peace and prosperity, was comparatively mild compared to what a pandemic during a major climate crisis could cause. This is why climate scientists and public health experts increasingly work together. They understand that you can't separate climate stability from disease risk. A world dealing with crop failures and mass migration from climate change is also a world at higher risk for emerging infectious diseases. The same systems that would help us weather a volcanic winter would also help us prevent or contain pandemics. Archaeological research continues to uncover new evidence of the 536 event's impact. Excavations of settlements show sudden abandonment during the 530s and 540s. Cemetery analysis reveals spikes in mortality and changes in burial practices consistent with mass death events. Isotope analysis of human remains shows evidence of malnutrition and dietary stress. Written records that were preserved tell only part of the story. The physical evidence is filling in the gaps, and the picture keeps getting worse. In the Dakotas, archaeologists have identified more than 1,500 gold hoards buried during the 6th century. These weren't normal treasure burials. They were desperate acts by people who expected to return and retrieve their wealth, but never did. The sheer number of these hoards, all buried within a few decades, suggests a society in collapse. People were dying or fleeing faster than they could recover their valuables. In the colonies, Recent excavations show that many towns that had survived the collapse of colonial rule were finally abandoned in the 6th century. For decades, historians assumed this abandonment was due to foreign invasions. Now we know the climate crisis and plague played major roles. People were dying or fleeing not because of invaders, but because the cities couldn't feed themselves anymore. But here's what gives me hope, and it's the same thing that made our species survive that genetic bottleneck 900,000 years ago. Humans are absurdly resilient. We're creative problem solvers. We cooperate under pressure. We adapt to conditions that should kill us. The people of 536 didn't have climate models or volcanic monitoring systems or strategic grain reserves. They didn't understand what was happening to them, and they survived anyway. Not all of them, not even most of them in some regions, but enough to rebuild, enough to create the world that came after, enough to ensure that we're here today having this conversation. Every person alive today is descended from someone who survived the 536 event. Just like every person alive carries genes from those 1,280 bottleneck survivors. We are all products of catastrophe, all evidence that sometimes when everything goes wrong, human beings find a way to endure. Texts from the decades after 536 show something remarkable. People kept records. They kept learning. They kept building. Within a generation of the worst climate disaster in historical times, libraries were copying ancient texts, craftsmen were building towers, farmers were developing new agricultural techniques. The darkness hadn't destroyed human curiosity or ambition. If anything, it had refined it. This is the final lesson of 536. Catastrophes happen. Climate disasters, pandemics, volcanic winters, these aren't aberrations in history. They're part of it. The question isn't whether we'll face another crisis like 536. Given enough time, we certainly will. The question is whether we'll be prepared, whether we'll have built the resilience and cooperation necessary to weather it, whether we'll emerge from the darkness still capable of building the future. Because that's what the survivors of 536 did. They endured the worst year in history. They buried their dead. They planted crops in cold soil and prayed for harvests that barely came. They kept their children alive through years of darkness. And eventually, when the sun returned to full strength and the temperatures stabilized and the plague burned itself out, they rebuilt. The world that emerged from the 6th century crisis was different from what came before. Smaller, poorer, more fragmented in some ways. But it was also tougher, adapted to survive in a world where catastrophe was always possible. The institutions and technologies and social structures that developed were shaped by the memory of those terrible years. We should remember 536 not just as the worst year to be alive, but as proof that even the worst years don't have to be the end. The sun eventually came back. It always does. The question is what we do in the darkness, and what we build when the light returns. So here we are, at the end of humanity's darkest year. But here's the thing about 536. It wasn't really 1 year. It was the beginning of a cascade that would last for generations. The volcanic eruption that dimmed the sun. Then the climate collapse. then the harvest failures, then the famine that killed millions, then the rats multiplying in abandoned grain stores, then the fleas carrying the virus spreading from those rats to humans, then the plague killing half the population of the civilized world. Each catastrophe creating the conditions for the next one. Each disaster making recovery from the previous one impossible. It's like watching dominoes fall, except each domino is a civilization, and the people falling are real humans with real lives, real families, real hopes that were never realized. The Eastern Union never fully recovered. Neither did the Western Republic. The Old World, already weakened by centuries of conflict and economic strain, took a blow from which it would never truly heal. Within a century, a new movement would explode out of the desert, filling the power vacuum created by the plague years. The New World was being born in the aftermath of catastrophe. But some survived. Some communities held together through the darkness. Some leaders managed to keep their people fed and organized even when the sun disappeared and the plague came knocking. The question that haunts historians is, why? What made the difference between the societies that collapsed completely and the ones that bent but didn't break? The answer seems to be the same as it was during the Great Bottleneck 900,000 years earlier. Connection. Communities that maintained networks with other communities, that shared resources when times got tough, that didn't turn inward and isolate themselves. These were the ones that survived. The ones that tried to go it alone, that hoarded their dwindling supplies and refused to cooperate with neighbors. These were the ones that disappeared from the historical record. It's a lesson we're still learning today. No civilization, no matter how powerful, is immune to catastrophic environmental change. The Union at its height controlled 70 million people, had sophisticated agriculture, extensive trade networks, advanced engineering, and it was nearly destroyed by a volcanic eruption halfway around the world. An eruption nobody saw coming, that created consequences nobody could predict, that triggered a cascade of disasters nobody knew how to stop. We live in a more connected world now. Our trade networks span the globe. Our communication is instantaneous. Our scientific understanding is vastly superior to anything the ancients possessed. But we're also more dependent on those systems than any previous civilization. What happens when the dominoes start falling? What happens when one disaster creates the conditions for the next, and the next, and the next? The people of 536 can't answer that question, but they can remind us that it happens, that civilizations don't just gradually decline. Sometimes they collapse suddenly, catastrophically, taking down millions of people who thought their world was permanent. But they can also remind us that humans are survivors, that we've been through worse and come out the other side, that 1,280 breeding individuals once kept the entire human species alive for 117,000 years, that the descendants of those survivors built everything we see around us today. We carry their genes, their resilience, their desperate stubborn refusal to give up even when the world seems to be ending. Every person alive today is descended from someone who survived something terrible. War, famine, plague, climate disaster. Somewhere in your family tree, someone made it through when most didn't. The year 536 was humanity's darkest year in recorded history. But it wasn't the end. It was just another chapter in the long story of human survival, another test that some passed and some failed, another reminder that we're tougher than we think but more fragile than we'd like to believe. Before you drift off to sleep, if you found this journey through humanity's darkest year interesting, give this video a like. It helps more people discover these forgotten stories. Leave a comment telling us where you're listening from, what part of the world you call home. Are you descended from the survivors of 536? Statistically, if you have American ancestry, the answer is probably yes. And subscribe for more history that helps you understand how we got here, where we came from, what we survived to become who we are today. For now, rest easy. The sun came back. The plague eventually ended. The survivors rebuilt. They always do. Sleep well.